Welcome back. So we are going to discuss about formation of ionic compounds. So let us start with an example, common one, sodium chloride. Sodium chloride. How we form sodium chloride? Sodium chloride is NaCl. NaCl. That is the formula for sodium chloride. So within sodium chloride, there is an element, sodium, which is our metal. Sodium. Then there is also a non-metal, chlorine. Sodium, Na. Then non-metal, chlorine, Cl. Chlorine, Cl. So sodium is element 11 in the periodic table, element 11, and it has electronic configuration. This is element 11 with electronic configuration 2 to 8 to 1 sodium. Then chlorine, element 17, electronic configuration 2 to 8 to 7. 2 to 8 to 7. So this is the EC, electronic configuration of sodium. This is the electronic configuration of chlorine. Electronic configuration of chlorine. So sodium, if we try to draw its atomic structure, this is the atomic structure of sodium. So the first shell has 2 electrons. That is the first shell. Second shell, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Then the third shell, 1 electron. That is the atomic structure of sodium. That is the atomic structure of sodium. Next we have atomic structure of chlorine. First shell has 2 electrons. Second shell has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last shell has 7 electrons. 1, 2, 3, 4, 5, 6, 7. So that is the atomic structure of chlorine. This is the atomic structure of sodium. So what happens during ionic bonding? We transfer electrons. From a metal to a non-metal. In simple terms, the metal loses electrons to a non-metal. So when you look at the atomic structure of sodium, the last shell has 1 electron. This last shell of sodium has 1 electron, so we transfer this 1 electron to a non-metal, chlorine. So if we had 2 unpaired electrons on this outermost shell of sodium, then we transfer those 2 unpaired electrons to chlorine. But we are having 1 unpaired electron in the outermost shell of sodium. The unpaired electrons are the ones which participate in bonding. So that's why we are transferring this 1 electron to that atomic structure of chlorine. We transfer unpaired electrons because for them they are unstable and they are the ones which participate in bonding. So we transfer unpaired electron to another unpaired electron. If we had 2 electrons on the outermost shell, this is an assumption, on the outermost shell of sodium. So if they were paired like this, don't transfer them. For them, they are stable. When electrons are existing in this paired form, for them, they are stable. They don't participate in bonding. They don't participate in bonding. We only transfer unpaired electrons. We only transfer unpaired electrons. So when this happens, we shall come up with this. We shall come up with this. Now the atomic structure of sodium will look like this after losing one electron. The atomic structure of sodium will take this form. This form. Now this is the new atomic structure of sodium. This is the new atomic structure of sodium. We have lost that one electron in the outermost shell, so we shall be left out with this first shell and the second shell. So this is the new sodium. And we said that in the previous session, when a metal loses electrons, there is formation of a positively charged ion. So we shall put a plus there, indicating that we formed a positively charged ion. Also here, when this gains one electron, we shall come up with this as the new atomic structure of chlorine. When chlorine gains one electron, this is the new atomic structure of chlorine. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That one. We said that nanometals gain electrons to form negatively charged ions, so we need a negative there. Now this is this thing. As you see it, all of it is sodium chloride. So this is sodium chloride. Sodium chloride. So within these two ions, there is a force of attraction. That's why I'm drawing them when they are close to each other. They should strictly be close to each other, because these positively charged ions of sodium are being attracted towards the negatively charged ions of chlorine. So within these two structures, we have a force of attraction between them, which is known as the ionic bond. So basically, that is how we form sodium chloride. So let us see another example. Another example of another